So we all know that the Earth spins about its axis, and that's what causes day and night. But you're spinning along right with it. So how fast are you actually spinning in miles per hour? Did you know the answer to that question is easily solvable using simple right triangle trigonometry? That's it. All you need is your latitude. Check it out. I have the Earth here, the equator is drawn in black, and this orange circle right here is my latitude, right? I could be north or south of the equator, right? But let's just pretend we're over here somewhere, right? So let's say we're 41 degrees north, or we could be 65 degrees north, or it could be at the North Pole at Santa, right? The latitude is 90 right there. Or with the penguins down in Antarctica, there's 90 degree latitude south, right? But the point is, we can make the right triangle there either above or below. But watch this. This is even more interesting because now, if in one day I actually do a full spin, right? It takes me 24 hours to spin these 360 degrees right here. So we're going to assume the Earth is a perfect sphere, and I know it's not, but for simplicity's sake, let's do it, right? According to Google, the Earth's radius is 3,959 miles. So all we really need to figure out is this right here, right? And check it out. That leg of the right triangle is really the radius of my circle of latitude, is it not? And so that's what I really need to solve and figure out. But it actually happens to be the same as that down there. And if you look at this from the side, here we have a simple right triangle trig question, do we not? The cosine of my latitude is really that radius divided by the Earth's radius, right? And this is what it looks like right here. No matter what my latitude is, right, I can always have it, be accordingly. And then once I do the math, let's check out the math here, right? I do the circumference, 2 pi r divided by 24 hours. That's the total distance I travel in 24 hours. So therefore, looking at it this way, right? If I am 50 degrees north latitude, I'm spinning at roughly 666 miles per hour. Well, what about if I'm with Santa at the North Pole? Oh my gosh, 0 miles per hour? Yeah, because all you're doing is this. In 24 hours, you're just spinning in a circle, right? But where do people on Earth spin the fastest? Turns out right at the equator. Isn't that the biggest circle of latitude right there? Here you do the biggest circumference of the Earth, that's a great circle right there, right? That's roughly 1,036 miles an hour. So no matter where you are in the northern or southern hemisphere, you can easily calculate your linear speed in miles per hour using simple right triangle trig. Math teachers, you can have your students engage with this activity and application right here. If you go to that tiny URL right there, you'll see a performance task where students can actually go gather data and play with this 3D GeoGebra app and have them determine what their linear speed is in miles per hour.